I'm Neerav Kothari. I'm a Google developer expert on cloud platform category. I am a GDG Cloud Mumbai organizer in India, Mumbai. And I'm working as a senior technical architect at a company called Quantify Analytics, which is Mumbai based. Today I'm going to talk about something called as how can you build your career into data engineering. Now, we've been seeing that, machine learning, large language models, these days, these words have become buzzwords, right? But what makes this, what is the enabling factor? That's data. Data enables machine learning, right? So it's important that we understand how do we collect the data, how do we store the data, and then how do we process and make the data usable, without which your data has no value. You will keep on collecting data from your applications. Uber, everyone knows, right? Uber keeps collecting your data. Like, where are you starting your taxis? Where are you getting dropped off at, right? How much time it took. And it keeps tracking you, right? Similarly, Google Maps, it keeps tracking you. Where have you gone in last 30 days and all of that? But what are they doing with that data? Are they only tracking it? Are they only storing it? Of course not, right? They must be using it somewhere. So the point is, unless you use the data that you have collected, whatever you have collected is of no use. And ultimately, you have just wasted your money. But how do you make your data usable is something called as data engineering. So you engineer the data so that that data is useful, that data is usable. Okay? So I'm going to talk about how can you make your data usable, and for that, how does data engineering play a role? And in case, if you are interested in that area, how can you build your career in that particular stream? It's very upcoming stream. I've seen that in India at least, there are some engineering colleges which have started a separate stream called data engineering. Earlier it was electronics engineering, computer engineering, IT engineering. Now there are specialized courses on data engineering, 4-year courses. So these days now, even governments, academics, even organizations have understood the value of data engineering. So it's better that the early that we get into it, the early we try and understand the concept behind data engineering, good for you. Okay, anyways. So here's the agenda of today's talk. I'm going to start this talk with a very interesting case study, okay? Case study of a organization which started its business with a small application, and then how it matured to make it like a enterprise application, and behind the scene what all things they had to do it, and behind the scene how many roles that organization had to employ, data engineer, ML engineer, what all roles they had to bring in their organization, and plus what was the role of each, what were the responsibility of each of these roles, so that you understand, at a larger picture, in an organization, what all roles do exist, where can you find yourself 3 years down the line, right? So I just wanted to give you an understanding of what kind of works are available in this industry, and accordingly you can choose your career path. By the way, I have been working in this industry since last 19 years, 20 years. So Just wanted to share my experience on that. Uh, Finally, I'll be concluding my talk with, little bit deeper into data engineering. Let's say if you choose to be part of uh, this particular stream, data engineering, that what kind of project you will be working on, what kind of work you will be getting. I'll be talking a little bit onto that. Okay, without spending much time. Uh, so when I say that I'll be starting with a case study, all these applications, Uber, I don't know, in Sri Lanka, do we have Swiggy or Zomato or I don't know, such applications, but I mean food ordering application and all of that. So they started with a very basic concept, just the travel, pick me, started with what, ride. Now they kept on adding more and more features to it, right? So, they start with one idea, and that's where, not sure if this is visible, but I'm sorry, I can't do anything, but I can read it out for you. So, this is the one application. So they might have started one basic application for, pick and drop kind of application. Of course, that application would require its own database. Now that database can be anything. It can be RDBMS database, it can be NoSQL database, any database, right? But it will have some database, and your application will keep storing transactional data into that database. Transactional means, you store data like, here is the person, here is the pickup point, here is the drop point, here is the charges, etc. All transactional related data you keep storing in that database. Fine, all good. Now later on, organization may think that, let's add more feature. Even though for you it is still one application, pick me or, Swiggy or whatever it is, it's just one application. But behind the scene, there can be multiple web applications behind the scene, right? And that's where, organization starts adding more and more application based on the different functionality of your application, right? So eventually they may split it into multiple application, and each application might be writing to a different database of its own, right? So there is a possibility that one application is writing into RDBMS, other application is writing into MongoDB, right? So all of that is possible. Now the problem is, this is the another way, how organizations create multiple applications. They might have initially started monolithic application. Then later on they refactor it and then convert it into, microservices architecture. So even in such scenario, they might have one database per microservices, right? So in any case, what we are trying to project here is, there can be multiple applications, each having their own database. Now this is all good, because organization is happy that, there is one application, one database per, per business function. I'm fine. I'll just query it, get the data, and my work done. But business people, business as in the managers and those people, will start thinking that I have data related to, let's say, account, I have data related to sales, I have data related to employees, but they are all sitting in different database. How can I merge this data and then fire some analytics on that? They cannot, because all of these are sitting in all different databases. And there is no way that you can fire analytics on, all database together in one query. And that's the reason the data warehouse was, introduced. This I'm talking about, I think 30 years back, 1990s. That was the reason that data warehouse was introduced in this industry. But how do we employ data warehouse? It's again a kind of storage mechanism only. But what you do is, you pull data from all databases using something called as ETL, extract, transform, and then load into the data warehouse. So now data warehouse has a larger storage capacity. It can store data from all the databases. Now that all data is present at one single location, managers were happy. Managers said that, yeah, good, that I am now able to query data coming from all different sources. Okay, moving on. But then what happened? Before I go into this, just pay attention to this. I'm not only showing data warehouse here. I'm having this blue box, which I'm calling it as data platform. At this moment, data platform has only one component, that is data warehouse. But later on, this data warehouse will also not be sufficient. And that's where we are going to add more components to it that will form my entire data platform, which is the current trend. I'll come to it in a while. Okay, so now what do I do with data warehouse? I have data from all sources into data warehouse. What do I do with it? Managers started thinking that, what if we could have some sort of BI tool? BI tool is like visualization tool, which can, show some dashboards of historical data, etc., or real-time data. So BI tool will help you to create those visualizations. You don't have to create it using, Angular and React and all of that. They are already pre-built. You just have to configure what is my table, what is, what metrics I want to show, etc. That's all. And the dashboard will be ready. So that's where BI tool got very popular. And even today, BI tools are largely used. This helps all managers for taking all their business decisions. Moving on. Later on, organizations felt that, I have the capacity to store so much of data in my data warehouse. Why can't I store more data? For example, there can be multiple systems like, HRMS system, CRM system, ERP, SAP system. Those systems are also part of my organization. Why can't I pull that data into my data warehouse so that I can enrich my data? I can add more context to my data, right? And that's why they started ingesting data from all these different systems into data warehouse. So now look at it. Data warehouse is becoming more and more, lot of data we are storing it into data warehouse, okay? Moving on. Later on, let's say if you had all that data in data warehouse, now if BI tool was firing a query to data warehouse, it had to traverse entire data in your tables, right? That was not very optimum because it has to scan a lot of data. So your queries will take more time, your queries will cost more. That's the reason there was another layer of abstraction came into picture, which is called as data marts. Now this data marts is nothing but kind of subset of data from data warehouse. But what subset are we picking into data warehouse, from data warehouse to data mart, is depending on the business function. So you might create one data mart for every data related to accounts into one data mart. Every data related to, let's say, customer into another data mart. So that's the reason organizations started creating more and more data marts. Okay? Now again, this is a storage mechanism, and that's why it is coming into my data platform. Now, why are we doing that? Why are we implementing data mart? Why do I need to create separate data marts per business function? The only reason is I want to make my BI reporting even more powerful, even more efficient, because now it has to query only specific subset of data, my queries will be faster. Cost will be less data to be transferred, right? So that's the reason data mart helped to make your dashboards much more faster. Any thoughts? I mean, clear everyone till now? Okay, moving on. But then later on, all these organizations, they are very greedy. All managers are very greedy. They started thinking, what can we add more into data warehouse? Okay, and that's the reason they started thinking that all these application servers are generating log files. Can we store that into data warehouse? Yes, you can store it, and that's the reason that was the need, that I want to store server data, I want to store application logs, all of that into my data platform. But the question is, these log files are not in relational format. It's not in database tables format, correct? Log files are always your txt file or .log file, correct? It is never in tables. Correct or not, everyone? Everyone is sleeping. What format is the log available? Log files. Have you guys worked on it? No. Have you seen application server? Yes, no. Okay. Okay. So application servers generate some log files, and those are flat files. They are not relational tables. And that's the reason if I have to store those log files in my data platform, I cannot store it, because data warehouse has a stringent requirement that any data that you ingest has to be in tabular format, in structured format. Now log files is not in the structured format, so we cannot store it in data warehouse. So what's the solution now? Any thoughts, anyone? No? That's the reason organizations started employing something called as data lake. Now data lake allows you to store flat files, whereas data warehouse will allow you to store all the structured data, right? So collectively, my data lake, data warehouse, and the data marts is forming my entire data platform. Okay? If you look at any recent applications, enterprise grade applications, they would have this kind of data platform, which consists of lakes, data warehouses, data marts, everything employed. So it's important that you understand this concept. No one is going to tell you that tomorrow you start working on data engineering. But at least as an engineer, you guys are expected to understand what is database, what is data warehouse, and what is data lake. Okay? Okay, moving on. So even if any organization has any unstructured data like images, video files, audio files, even those can be stored in data lake. So data lake forms an important aspect in my data platform. Okay? Moving on. Now that organization started, again, managers, as I said, very greedy person, right? They started thinking, now I have so many data. Look at this. All these yellow boxes are my sources of data. I have so much of data. What can I do with that data? If I'm not utilizing that data, why should I spend in data warehouse or data lake, right? And that's where they started making something called as predictive and prescriptive analytics on top of the data present in lake and data warehouse. Okay? Prescriptive and predictive analytics? It will predict certain thing, like, when will my sensor die off, or, is this particular thing seems to be an anomaly data or not, So those are kind of machine learning model that you apply on top of that data. So organizations started implementing those analytics on top of your data. Moving on. Later, with the invent of all this Twitter and all the real-time streaming data that is coming in, stock prices, for example, right? They all started ingesting this data from various sources into their data platform. Now again, there is definitely a separate way or means of implementing this, because here the data is continuously coming, right? So you need to implement something called as streaming analytics here. Streaming ingestion and then analytics and then store it. So this collectively forms your entire data landscape of the organization. Okay, so you go to any organization, any enterprise application, they will be having more or less this kind of architecture, where all of these concepts are somewhere utilized. There are high chances that some application might say that we are not interested in streaming analytics, but other parts will be there. So understand the concept behind this. Why do we need each of these blocks? Is this clear? Any questions on this till now? Clear? Okay, moving on. So now let's look at, if all these are the tasks that my organization has to do, who's going to do it? Which role is supposed to implement all of these functions? So what I've tried to do is, I've tried to list down 4 legends on the top right corner. Data engineer, BI engineer, application developer, and ML engineer. So these are the 4 roles who will be developing this entire platform, right? So, but which particular function falls under which category, or whose responsibility it is? Let's look at that. So you are seeing that pink block, the application development, that is being handled by the application developers. Okay? The green box that you see is all data engineers' job. So creating databases is actually a data engineer's job. Creating ETL pipelines is also data engineer's job. Ingesting all unstructured data will be handled by data engineer. Also connecting to various, integration system, enterprise application systems, integrating them and collecting data from that will be handled by the data engineers. Even streaming and analytics is part of data engineering job. Maintaining the data platform is also handled by data engineer. The BI reporting will be handled by another role called as BI developers. Okay, that generally is not handled by data engineer. The prescriptive and predictive analytics is being handled by ML engineer. Okay, so now you understand that, out of the entire landscape, what's the importance of data engineering? What is the importance of data engineer? We've been always talking about, application development, ML, but there is a whole world even beyond that. So we need to understand this, that there are so many points that, that exist. So many opportunities are there to implement these functionalities. So, okay, moving on. So now that we have categorized each of these functions, let's just talk about only tasks that is handled by data engineer, okay? And what are they called as? So the green box that I marked, those were actually data engineer's job, but let's name them, each of them. What are they actually called in this industry? So the database part that you see is called database management task, okay? So if you go for any data engineering role, interview, etc., if they talk about, what have you done for database management? So that's the part that you are going to, you have handled, okay? So understand that. That should strike your mind, that what was the role of that particular function in this entire landscape. Oh, sorry. The ETL part is called data pipelines. You must have heard somewhere that, we are building data pipelines. Those data pipelines is nothing but creating pipelines using ETL tools. Managing the data warehouse, data lake, data marts is called as data warehousing. Many times many organizations pull data from data lake, push it into data warehouse. So there also they create some data pipelines in between. So that is also called as data warehousing internally. Then ingesting of all these data is called batch ingestion. And finally, the streaming part function is called streaming, ingestion, and analytics. Okay, let's move on. So now that we know that data engineer is responsible for these 5 functions, only 5 functions, okay? Very simple. I mean, you can learn it in one day, right? 5 functions, can't you? 5 functions? No? Okay. So let's look at what are you actually supposed to do in each of these 5 functions, okay? So database management, when we say, you are supposed to choose the right database, whether it should be RDBMS or MongoDB, document type database, what kind of database. You need to decide the size, whether if it's an on-prem database, then you need to choose that 4-core CPU is required, 16 GB RAM required, so that sizing you need to choose. You need to create the tables, right? Create tables, create schema, all of that. Apply constraints, etc. And then finally, you are responsible for managing the performance of that database, okay? Whether the query that you are firing, is it answering in within time or not? Those kind of activities. And finally, how do you secure your data present in the database? That is one of the responsibility of data engineer. Now let's look at data pipeline. What are the functions executed there? Anyways, by the way, for database management, these are the 4 types of database available in Google Cloud for implementing your databases. Moving on, for data pipeline, you have to choose between approach, whether you are going to use ETL tool or ELT tool. ELT is a different approach, extract, load, and then transform. Whereas in the other case, you are transforming before the load. Here you are loading first and then transforming. So there are definitely differences between them. And in today's world, ELT, extract, load, and transform, is much more popular than the earlier ETL tools, okay? Especially when you are implementing it on cloud. Okay, then here as a data pipeline developer, you are responsible to connect to various sources and destinations, where to pull data, where to store data, etc. And also build the right transformation logic. Let's say from the source from where you are pulling the data has a date format different than where you are storing it. Then your transformation logic has to modify that data, transform that data, and then store it into destination. So that transformation logic is something that data engineer is supposed to do. And then finally the orchestration. So orchestration is basically how many pipelines I want to run, when do I want to run, is there any dependency, if one pipeline fails, should second pipeline run or not. So all that logic is called orchestration. So when you build data pipeline, you also have to work on the data pipelines orchestration. And finally, whatever pipeline that you have built, you have to monitor it, right? Whether it is functioning as per expected or not. And these are some of the services, data fusion, data flow, proc, and composer, that you usually use in Google Cloud to implement that. Moving on. For data warehousing, you have to think about whether I need data warehouse or data lake or data mart. Choosing the right storage mechanism and analytics engine. So, do you want BigQuery, or you want Snowflake, or you want Redshift? So that's the thinking that you need to have before choosing the one data warehouse for your organization. And then finally, data modeling. So data modeling is all about what table I should create, what should be the facts, what should be the dimensions. I'm not sure whether you have learned that in your curriculum or not, but in a nutshell, basically it's what table to create, what is the dependency on other tables, etc. Data governance, very important topic. How do you ensure that the data that you are storing in data warehouse is up to quality, has quality. Ensure that the data is secured. You ensure that the data when you store is available when you want it. So all of that is covered under some process, and that process is called data governance. So when you talk about data warehousing, data governance is important aspect. And how do you build data warehousing in GCP, BigQuery, GCS, and data governance can be implemented using Dataplex. You don't need to remember all these services at this point of time. What I want is you can click a picture, and later at some point of time, if you have to work on this, then probably you can refer this slide. Moving on, I don't think we need to get into too much depth into batch and streaming ingestion, because it's like, the name itself suggests, it's basically ingesting data from various sources, either in batch fashion or in streaming fashion. Okay, so I'm just keeping this slide once more, in case if anyone wants to click a picture of this slide. Done? Okay. Moving on, I'm not going too much into depth into how you build this entire data platform that I talked about using Google Cloud technologies. I'm not going to go into that, but in case if you have to build it, this is the approach. This is how you will have to build it. Okay? So this mentions all the services and how they are supposed to be connected to each other, right? So click a picture of this and probably you can use it whenever you are supposed to use it. Okay, moving on. So let's look at finally, I hope everyone has, taken the decision that you guys are going to work into data engineering. I'm assuming that. But in case if that's the case, so let's look at, what kind of project you guys will have to execute if you are a data engineer, okay? There are basically three types of projects in data engineering. One is data warehousing. Client wants to implement data warehouse in their organization. So when you want to implement data warehouse, you have to think, where will I get the data from? Which are the databases from where I will have to pull data? Which are the streaming sources from which I have to pull data? Do I need data lake? Do I need data warehouse? Do I need BI reporting? Think about all of this and implement entire data platform. That's one type of project, which in general is called data warehousing. The other type of project is data migration. So many organizations may say that, I already have data warehouse, either on-prem or maybe in some other cloud provider, other cloud, public cloud. Now I want to move to Google Cloud. So that kind of project is basically called migration, data migration. And again, here you not just move the data from one cloud to other, but at the same time, you also think about whatever data pipelines were writing to my earlier data warehouse, those pipelines have to be modified now so that they start writing to new data warehouse, right? So that kind of thought process you need to have while implementing this kind of project. And the third is data governance, as I mentioned. By and large, it consists of how do you organize data from multiple sources. Now, let's say if you have multiple departments in your organization, billing, accounts, customer, whatnot, you have data from all these sources. How do you organize all of that? That's one part of data governance. The second part is cataloging of data. Let's say if you have employee table, a table called employee coming from, let's say, a sales table, sales system, also from employee system. Now, how will you find out which employee table you want, which one to query? That's where you need a search mechanism like Google search, right? You need such kind of search technology. And that search technology is called data cataloging. So you need that, you need to implement that when you, expand your horizons. Plus, how do you secure your data? Only person who has access should be able to visualize the data, right? No other should be able to access it. Person who is only able to, should be only able to read the data, he should not be able to write the data. So how do you implement all this security policy is one of the part of this data governance. The fourth function is data quality, which is, how do you make sure that, no data is missing, no data is garbage. So correcting all that data is basically data quality. Okay, finally, to conclude my talk, so what I want to say is if you want to get into data engineering role, there are dedicated paths, learning paths available on Quick Labs. Start executing that, and that will give you a very good idea about what services are available in GCP. Now that's about GCP. But is learning GCP will make you foolproof for playing your role as a data engineer? No. You need to make sure that you are thorough with the data engineering concepts. By data engineering, I mean data warehouse, databases, tables, schemas, SQLs, etc., ETL, etc. So another thing is Google Cloud will provide you all the tools to make your life easier, because nowadays in Google Cloud, all these functions that I talked about are available as single click. You just click it and it's available. But it's very important that you understand that what tool to use where, how to configure it in right manner, that will be your responsibility. So need to understand the concepts thoroughly. So with that, that's all I wanted to talk about today. Thank you so much. In case if you have any queries, I don't think we have time now, but I'm available throughout the day here. I mean, you can connect with me offline. Thank you so much.
Thank you, Nirav, for that insightful session. To give away the token of appreciation, I would like to invite Dilanka Pereira, GDG Sri Lanka organizer.